everyone. Now we are going to solve the problems on the NTU and effectiveness method. In the last video, we solved the problems on the LMTD method. Next is the NTU and effectiveness method. This is also a very simple problem compared to the last problems. In the heat exchanger, the problems are very easy. See, in the LMTD, what you to solve the LMTD, logarithmic mean temperature difference, that is what delta T LM is called. Both are the same thing. Logarithmic mean temperature difference or delta T LM are both are the same thing. To solve this one, you require the four temperatures, all four temperatures. That is what THI, TH naught, and TCI and TC naught. Suppose if you know only these two temperatures, if you know these two temperature, if you doesn't know this temperature, you cannot solve in the LMTD. In most of the cases in the heat exchanger problems, you know only the hot inlet temperature, cold fluid inlet temperature, but you don't know what will be the hot outlet temperature and cold outlet temperature. In that condition, LMTD you cannot be solved using the LMTD. It becomes very difficult to solve in the LMTD problems. So in that condition, the NTU and effectiveness method is came into the picture. Even in this condition, means what, in the THI and if you know only the two temperature, you can find out what is the rate of heat transfer. Once you know the rate of heat transfer, you can be find out the area required for the heat exchanger and length required for the heat exchanger. Those things can be calculated. Okay, in the problem, only the THI and TCI is given. Only this data is given in the problem. You should understood that you should go for the NTU method and effectiveness method. Okay, or some more the clues will be there, hits will be there. While you solving the problems, you will get that one. One thing you keep it in mind: the NTU and effectiveness method came into the picture because if you know only the temperature of hot fluid inlet and cold fluid inlet, you can find out the rate of heat transfer, area required for the heat exchanger and length required for the heat exchanger. This is not possible in the LMTD. So that's why the NTU came into the picture. While you solving the NTU, the NTU can be defined as NTU is equals to overall heat transfer coefficient UA into surface area of heat exchanger divided by C heat capacity rate minimum, UA C min. UA C min. C means heat capacity rate. That is nothing but capital letter C, that is nothing but product of the mass flow rate of the fluid into specific heat. That one you're going to you're going to call as the m dot Cp. Suppose if you are talking about the hard fluid, that one you're going to call as the CH. That is what m dot H Cph. Suppose if you are talking about the cold fluid, Cc is equals to m dot C Cpc. Now, product of this one, you will get it as the 100. Product of m dot C and Cpc, you will get it as the 200. That time, and the unit is watt per Kelvin and watt per Kelvin. Here, which one is the maximum? This is the maximum. Now, this one you're going to call as the C max. This one you're going to call as the C minimum, heat capacity rate minimum, and this is maximum, so heat capacity rate maximum. Suppose in the problem, this ratio is you're getting 200 and this ratio you're getting 100 watt per Kelvin. Now CH become what? C max, and this becomes what? C minimum. That's all. Based on this based on the value of this two product, we are going to decide which one is the maximum and which one is the minimum. C max maybe become CH or maybe become a CS, only that is depend upon these values. Now NTU is equals to UA by C min. Next, another definition is there: capacity ratio, heat capacity ratio, heat capacity ratio. Capital letter C is equals to capacity ratio. See, the name itself indicates this is the ratio. C is equals to C min by C max, means product of this one by this one. Which one is the minimum? That should be in the numerator, and which one is the maximum? That should be in the denominator. Heat capacity ratio is defined as C minimum divided by C max. Next, effectiveness is defined as actual heat transfer divided by maximum heat transfer. Q actual means what? Actual rate of heat transfer, it may be for the art fluid. If you consider for the art fluid, that is what? M dot H CPH THI minus TH naught. Okay. For maximum Q, this is the actual heat transfer for the art fluid. For maximum heat transfer can be written as I will write this is the C minimum art fluid inlet minus cold fluid inlet. C minimum into THI minus TCI. Suppose for the cold fluid, the effectiveness I am defining. Effectiveness is what? Actual heat transfer by the maximum heat transfer. Actual heat transfer for the art fluid is this one, and maximum heat transfer, this is the equation for the maximum heat transfer. Suppose if you are calculating for the cold fluid, this become M dot C CPC TC naught minus TCI, and the same thing C minimum THI minus TCI. C minimum is what here? The product. Which one is the minimum is there? That should be substituted here. Whether it may be a CH or whether it may be a CC. Okay. Suppose here in this problem, which one is the CH is the minimum? Here you have to substitute this value to here, CH, this value. Suppose if it is in this case, which one is the C minimum? CC is the C minimum. Oh, this value should be substituted here, whether here or either this one. C minimum is nothing but the product of M dot and Cp. Which one is less? That is the minimum heat capacity rate. Okay, these equations we will use to find out the unknowns. NTU, C, effectiveness. Okay, and also using these equations, complete this equation, you can be find out TH naught value, because in this problem, in the NTU method problem, you know the THI and TCI. That's why suppose in the problem if you can ask find out TH naught, using this equation you can be find out TH. Here you can see, here you know in the effective NTU method THI and TCI you know it. Suppose you have to find out TH naught, using this equation you can be find out TH naught. Suppose in the problem if they ask TC naught, using this equation, okay, this term and effectiveness, using this term means this is equals to effectiveness. Using this one you can be TC naught. Always keep it in mind, to find out TH naught and TC naught you have to use this equation. In the problem they will ask find out TH naught and TC naught. This one you have to be used. Okay. One, keep it in mind, if you know NTU and C, you can find out effectiveness. Otherwise, if you know NTU and effectiveness, you can be find out C. And if you know capacity rate and effectiveness, you can be find out NTU. Okay. Always keep it in mind, to find out the any two, you can find out the third one. Okay. If you know the effectiveness, after knowing the effectiveness, you can find out TH naught and the TC naught. Okay, we will solve the problems on this one. Here first we will solve the problem number 4. Later we will solve the problem number 3. Once you understand the problem number 4, then it is become very easy to understand the problem number 3. In the problem number 4, it is given a chemical having a specific heat of 3.3 kilojoule per kg Kelvin at a rate of 20,000 kg per hour. So you should convert this into a kg per second. enters a parallel flow. Oh, it is clearly given that the heat exchanger is the type of heat exchanger is parallel flow at 120 degrees centigrade. Okay, still we don't know which one is the hot fluid and cold fluid. Heat exchanger enters at 120 degree. This is the entering. I don't know whether it is the hot fluid or just I written as the I 120 degree centigrade. The flow rate of cooling water is 50,000 kg per hour at inlet temperature of 20 degrees centigrade. Okay, this is also a inlet. Now you can easily check out that one. This is the less temperature compared to this one. Both are inlet. So this one is what? Cold fluid inlet, TCI, and this is the THI. Okay, both are the entry temperature. There is no any exit temperature here. Therefore, compared to this one, this is the highest temperature. Obviously, this becomes the hot fluid and this becomes the cold fluid. The heat transfer area A is given and overall heat transfer coefficient U is given. Find out the effectiveness. In the problem, it is clearly given that effectiveness means this one. So this is what? NTU method. You should go for the NTU method. Effectiveness NTU method you should be go for, because effectiveness what effectiveness is given. And also in this problem only what THI and TCI is given. That is also one of the clue for you go for the effectiveness NTU method. Next, you should find out the outlet temperature of water and chemical, means both TH0 and TC0 you should be find out. The specific heat of water is given. Okay, now you collect the data in the same way for the hot fluid as well as the cold fluid. This is very important. And the type of the heat exchanger is the parallel flow heat exchanger. The hot fluid is what? Here is the chemical. CPH is given. M dot H is given. You connect 20 kg per second. And the hot fluid entry temperature is given 120 degrees centigrade. In the same way for the cold fluid, surface area is given, U is given, all the data is collected here. Here what we have to do means M dot H is you know it, CPH is know it. Once you know the M dot and CP, what you should calculate? The C, capacity rate, you should be calculate. You find out CH, heat capacity rate for hot fluid. CH is equals to M dot H CPH. You just substitute and you calculate the what is the capacity rate for the hot fluid. In the same way here you know the CPC and M dot C, so you should calculate the heat capacity rate for the cold fluid. This is the cold fluid, CC. This is the equation is given. Now check which one is the minimum. 18,333 is minimum or 58,138, which one is minimum? CH is the minimum. So C min is equals to CH 18,333 and C max becomes CC. Write this one. Now you know the C min and C max, what you can be find out. Once you know the C min and C max, you can be find out the capacity ratio C. Find out the what is the C value. The C value is C you obtained as 0.315. This is unitless. 0.315. Next, NTU. Once you know the C minimum, NTU is equals to UA by C min. Substitute the values here. Find out what is the NTU. NTU is 0.572. Now you know the NTU and C. I already told that once you know the NTU and C, what you can be find out? Effectiveness. Once you find out the effectiveness, next you can be find out TH0 and the TC0. See, this is the effectiveness equation that is available in the data handbook. Here you can see the equation, heat exchanger effectiveness relations, that is the NTU and effectiveness. Double pipe for the parallel flow heat exchanger, this is the equation, effectiveness is equals to 1 minus exponent minus n into 1 plus s divided by 1 plus S. This is the equation is given. N is NTU and C is this one. Just you substitute the here, you get it as the effectiveness is 0.40. This is the equation taken from the data handbook and the page number is the 152. You can calculate the effectiveness from this equation. Also you can calculate effectiveness from graph also. Keep it in your mind. Okay. Once you know the NTU and C, these things you know it. Now you can calculate effectiveness from graph also in the data handbook itself. Here you can see effectiveness parallel flow. If you know the NTU and C value, effectiveness can be found out. If you know the NTU and effectiveness, the any C value can be found out. If you know the effectiveness and C, the NTU values can be calculated. Right now we know NTU means number of transfer units. And if you know NTU and C, you can find out effectiveness. NTU is how much? NTU is 0.572. 0.572. This is the 5. Okay, 72 means approximately comes to here. Okay, around here. Now from here to 0.315. This is 0.3, somewhere here, almost somewhere here. It will somewhere it comes here. Suppose if you drop here 40%, 40% or 39% or almost near to the 40%. 40% is nothing but what? 0.40. No, 40% is nothing but what? 40 divided by 100. That is nothing but 0.4 only. Okay. If you know the NTU and C, you can calculate effectiveness from the graph, or also you can be calculated from the equation. Okay. Once you know the effectiveness, next you have to find out TH naught and TC naught. We know that effectiveness is equals to Q actual divided by effectiveness is what? Q actual divided by Q actual by Q max. That is nothing but already I explained here before starting of the problem. Q actual is equals to, for R fluid, this is the equation. For Q max, C minimum THI minus TCI, and for the cold fluid, this is the equation I taken. The same equation I taken here. Therefore effectiveness is equals to m dot h Cps in place of that one I can write CH, THI minus TH naught, C minimum THI minus TCI. Similarly for the cold fluid, the same thing, CC TC naught minus TCI divided by C minimum THI minus TCI. Now we are finding TH naught. TH naught is equals to effectiveness. You can see here effectiveness C minimum into THI minus TCI. That should become THI. This THI minus this term becomes TH naught. Okay, just keep the TH naught here. Remaining things you shall send it here and multiply by the negative sign. You will obtain this one. Okay, this is the equation to find out the TH naught. Always keep it in mind. Very, very important equation to find out the TH naught. Almost in all problems in the LMTD, also in NTU method, they will ask to find out the TH naught and TC naught. Separate the terms, all the things, you find out TH naught. In the same way, to find out the cold fluid outlet, TC naught. How to find out TC naught? You keep the TC naught in the right hand side, remaining all the terms comes to the send it to the left hand side. Epsilon C minimum THI minus TCI. You can see epsilon C minimum THI minus TCI. The CC will becomes here. This TCI comes to the TCI comes to the right hand side, so it becomes the plus TCI TC naught. Okay, this is also a very important equation to find out the TC naught, find out the TC naught. Okay, don't forget this one. Don't forget this one. This TH naught and TC naught equation is obtained from Q actual divided by Q max. Okay, whether writing this equation, come to this one, otherwise you by at it. But in most of the cases when you are going to by at this equation, you may going to write the wrong. So always write these two steps to get the TH naught and TC naught. This is the procedure to find out TH naught and TC naught. Okay, next we will solve the another problem. This is very simple problem compared to this one. This is the basic problem. Okay, consider the following parallel flow. Okay, very good. In the problem it is given, it mentioned as the parallel flow heat exchanger. Okay, one more clue. If type of heat exchanger is given, there is the one clue, that is not always one clue to go for the NTU and effectiveness. The best method is what? In the problem, if it is given THI and TCI, you should go for this one. Or in the problem, if they mention find out effectiveness or find out TH naught and TC naught, if both the temperatures you have to find out, means understood that you should go for this one only. Cold fluid enters, this is the TCI, and CC is given. CC means what? M dot C CPC. Here there is no need to multiply all the things. In the problem itself it is given the CC. And the same way for the hard fluid, THI is 150 degrees centigrade and CH is M dot H CPH. That is also given. Area U is given. Determine the heat transfer rate. Q means Q actual you have to be find out. And the exit temperatures, that is what we have to find out, TH naught and TC naught. Now in the same way, heat exchanger type is parallel fluid exchanger. You take the hard fluid and the cold fluid separately. CH and CC is given. CH means M dot H CPH, CC means M dot C CPC. All the area and U is given. We have to find out Q this and TH naught and TC naught. From this problem, which one is the minimum less value? CH is the less value, 10,000. Therefore, CH becomes the C minimum, and this is the maximum value. Therefore, CC becomes the C max. Once you know the C minimum and C max, next what you have to find out? The C value or NTU. Okay, and now anyway you come to the, once you know this one, you can be find out C. NTU is equals to UA by C min. You substitute the U area and the C minimum value, we will get it as the 1.5. Next is capacity ratio C, C minimum by C max. Here C minimum is CH by CC, you will get it as the 0.5. I already told that if you know the NTU and C, the next unknown is the effectiveness. This you can be find out by equation or you can be find out by the graph. If you go for the equation, you will get the more accurate value. In the graph means what? If you the 1 unit will be changes, 0.2% will be changes. Okay, therefore you go for the equation and you check in the graph also whether it is correct or wrong. Just cross check it. Using NTU and C, the equation is available in the data handbook shown in the last problem. Parallel flow heat exchanger. Take this equation, substitute the values here. Effectiveness is equals to this one. Effectiveness is equal to 0.596. Even if you go for the graph method, NTU is how much? NTU is 1.5 here, and the C is 0.5. C is 0.5 here. Next, drop down here 60%, almost near to the 60, and from this one. In this also 0.596 means is also very near to 0.60 only effectiveness. Likewise, you cross check whether you did the correct or wrong. Next, in the problem they ask you have to find out the actual heat transfer. The effectiveness is equals to what? Q actual by Q max. Q max can be found out by this equation, C minimum THI minus TCI. C minimum is 10,000, THI 150 minus 40, you will get as the 11 into 20 power 5. Right, this is the maximum heat transfer. Next, Q actual is equals to epsilon into Q max. Epsilon into Q max, you find out what is the actual heat transfer. And the next is, once you know the actual heat transfer, Q is equals to what I can write. Once you know the Q, you can write m dot h cph thi minus th naught. Now you can find out what is the th naught. Or Q is equals to m dot ce cpc tc naught minus tc naught. If you know the Q actual value, you can find out tc naught and thi. In the same way here, Q is equals to m dot h cph thi minus th naught. This one this one is the ch. Simply just th naught is equals to thi minus q by ch. Find out what is the th naught, and then in the same way for the tci. If you know the actual heat transfer, you can go through this one. If you don't know the actual heat transfer, how you solved in the last problem, this one. Most of the time we will use this. Both are the same way. Both are the same thing only, but you follow this one. Most of the cases based on this here Q actual I know it, that's why I use this equation. Suppose if you use this equation also, you'll get the same value. Maintain the uniformity. Okay. Okay, we will solve another problem. This is the assignment for you. Just I'll give the hint, all those things. Next problem. In an open heart surgery, under hypothermic condition, the patient blood is cooled before the surgery. The patient blood is cooled. Now the patient blood becomes the heart fluid before the surgery and rewarmed afterwards. It is proposed that a concentric tube counterflow heat exchanger. Here type of the heat exchanger is counterflow heat exchanger. The length is given is the 0.5 meter. Use it for this purpose with this thin walled. The thin walled means this is the one of the clue that you cannot consider the d naught value. D naught value should not consider. D naught value is not required. Okay, not required. D naught value is not required. If a thin value it is mentioned, thin walled means D naught is not required, not considered. In a tube having a diameter of 55 mm, Di is given. Length is 0.5 meter. Di is 55 mm. This is nothing but you can calculate the AI. AI is equals to pi into Di into L. You can calculate AI. If the water at 60 degrees centigrade and 0.10 kg per second is used to heat the blood entering the heat exchanger. Okay, we will collect the data in this problem. The hot fluid is the water because the temperature of water is 60 degrees centigrade and the blood is entering is 18 degrees centigrade. The highest temperature fluid will be taken as the hot fluid, that is the water. Cold fluid is the blood. According to the problem, we should calculate the data. The TCI is 18 degrees centigrade and the m dot c, the blood entering at the exchange at the rate of m dot c is 0.05 kg per second, and the specific heat of blood is given, but specific heat of water is not given. You considered as this is the 4200. Just this is the assumption or the value of the cph of water is 4200 only. Take this one. The u is given, we will take that one, but in this problem area is not given, but instead of area they given as what, di and l is given. What is the di? The inner diameter is 55 mm and length is the 0.5 meter. See here the thin walled means neglect the d naught value. So therefore di becomes d naught, that becomes the d value. This becomes the d. Once d naught is neglected means the inner radius and outer radius become the same thing, that becomes the d. D is 55 mm. So just I will write a is equals to pi dl. Diameter is given 55 mm and length is 0.5 meter. Substitute the values, you find out the area. Okay, in this problem the area doesn't give, but they give diameter and the length. Just I will giving the hints, you should calculate this one. Here you know the m dot h and cph. What you can be find out? Ch can be find out. M dot h and cph, you know it, you find out what is the ch. In the same way you find out cc. M dot c and cpc, you find out what is the cc. Just I will do the calculation and I will write the answer. By doing the calculation you will get this one. Here C minimum is the CC and the C maximum is what? CH. Once you know this value, find out the C, that is what? C minimum divided by C max. By doing the calculation you will get C is 0.4167. This is the unitless 0.4167. Next, you know the C minimum and you know the U and A. Find out NTU. NTU is equals to UA by C minimum. Substitute the values here. I got the answer as 0.2468. Once you know the NTU and C, next is find out the effectiveness. This effectiveness can be find out from equation or from the graph. Okay, equation is what? Equation is available here. 1 minus exponent minus n 1 minus c divided by 1 minus, substitute the values here, you will get the answer from equation as 0.21. You can also find out by the graph effectiveness by counter flow, because the detection is counter flow 163. What is the NTU? NTU is 0.468. 0.2424 means almost it is 0.25. Some comes around here. NTU here, and the C value is 0.4167. 16 is all. I will write almost this is the 0.42 or 0.4. This is the 0.4. Of course it comes around here. This is the point here, here. Drop this one, you get the 20%. Here also you're getting as the 20%. By graph and equation both are the same thing. Once you know the effectiveness, what are the things you should be calculate here? You should calculate from here is what? What is the temperature of the blood leaving the exchanger? Temperature of the blood means you should calculate the TC naught. Effectiveness now you know it, 0.21. This is what? Next is Q actual by Q max. In the problem it is clearly given that the TC naught you should be calculated, that is the cold fluid. Therefore you should what you have to do, m dot c cpc TC naught minus TCI divided by C minimum THI minus TCI. Here CC is what? C minimum. CC is C minimum. Therefore this two will be get cancels. The left out is what? Effectiveness is equals to TC naught minus TCI THI minus TCI. Our we required is what? TC naught. TC naught is equals to what? Epsilon into THI minus TCI plus TCI. TC naught is equals to, this is the product. TC naught is equals to, this is the product. This TCI should be sent to the left hand side, so this become plus TCI. Now you find out what is the TC naught. TC naught value is 26.83 degree centigrade. Okay, this is how we should calculate the end-to-end effectiveness method. Solve the mole problem on this one. If you have any doubt related to this one, please make a call or put a doubts in the WhatsApp group. I will try to solve. I will try to explain those things. Thank you.